Welcome to this model. In this model, we are going to see about the inter-domain multicast protocols. The three protocols which we discussed in the earlier models for multicast routing are DVMRP, MO, SPF, and PAM, and they are designed to provide a multicast communication inside an autonomous system. When the members of the groups are spread among different domains, that is autonomous systems, we need inter-domain multicast routing protocol. So one common protocol for inter-domain multicast routing is called Multicast Border Gateway Protocol, that is MBGP, which is the extension of BGP, which we discussed for inter-domain unicast routing. So MBGP provides two paths between AS, that is autonomous system, one for unicasting and one for multicasting. Information about multicasting is exchanged between the border routing, which there are different IAs. So MBGP is a shared group multicast routing protocol in which one router in each AS is chosen as the rendezvous point, that is RP. The problem with the MBGP protocol is that it is difficult to inform an RPA, that is rendezvous point, about the sources of groups in other AS. So multicast source discovery protocol is a new suggested protocol that assigns a source representative router in each AS to inform all RPAs about the existence of sources in the AS. Another protocol that is thought of as a possible player replacement for the MBGP is the Border Gateway Multicast Protocol (BGMP), which allows the construction of shared group trees with a single root in one of the AS. In other words, for each group there is only one shared tree with leaves in different AS. But the root is located in one of the AS, and the two problems, of course, are how to designate an AS as the root of the tree and how to inform all sources about the location of the root to tunnel their multicast packets to. Now let's move on to IGMP. The IP protocol can be involved in two types of communication. One is unicasting and other is multicasting, as you all know. Unicasting is the communication between one sender and one receiver. It is a one-to-one communication. However, some processors sometimes need to send the same message to a large number of receivers simultaneously, and this is called multicasting, which is one-to-many communication. Multicasting has many applications. For example, multiple stockbrokers can simultaneously be informed of changes in stock price, or travel agents can be informed of a plane cancellation. Some other applications include distance learning and video on demand. The Internet Group Management Protocol is one of the necessary but not sufficient protocols that is involved in multicasting. IGMP is a companion to the IP protocol. So for multicasting in the internet, we need routers that are able to route multicast packets. The routing tables of those routers must be updated by using one of the multicast routing protocols. And IGMP is not a multicasting routing protocol. It's a protocol that manages group membership. In any network, there are one or multicast routers that distribute the multicast packets to host or other routers. The IGMP protocol gives the multicast routers information about the membership status of host connected to a network. A multicast router may receive thousands of multicast packets every day for different groups. If a router has no knowledge about the membership status of the host, it must broadcast all these packets. This creates a lot of traffic and consumes bandwidth. A better solution is to keep a list of groups in the network for which there is at least one loyal member. IGMP helps the multicast router create and updates this list. So now IGMP has gone through two versions, IGMP v2 and IGMP v4. And the IGMP v2 has three types of messages: query, membership report, and leave report. There are two types of query messages. One is general and the other is special. In the general message format, the first type field, it is an 8-bit field that defines the type of message. The value of the type can be in both hexadecimal or binary notation. So general or special query is 0x11 and membership report is 0x16 and leave report is 0x17. And the maximum response time is the 8-bit field that defines the amount of time in which query must be answered. The value is in tenths of a second. For example, if the value is 100, it means 10 seconds. The value is non-zero in the query message. It is set to 0 in the other two message types. And the next field is checksum field, and which is a 16-bit field carrying the checksum. The checksum is calculated over the 8-byte message. And the group address the value of that group message field is 0 for a general query message, and the value defines the group ID in the special query. That is a membership report and the leave report messages. IGMP operates locally. A multicast router connected to a network that has a list of multicast address of the groups with at least one loyal member in that network. For each group, there is one router that has the duty of distributing the multicast packets destined for the group. This means that if there are 3 multicast routers connected to a network, their list of group IDs are mutually exclusive. For example, in only a router R distributes packets with a multicast address 225.70.8.20. A host or multicast router can have membership in a group. So when a host has membership, it means that one of its process receives a multicast packet from some group. So when a router has membership, it means that a network connected to one of other interfaces receives these multicast packets. So we say that the host or the router has an interest in this group. So in both cases, the host and the router keep a list of group IDs and relay their interest to the distributing router. For example, if router R is the distributing router, there are 2 other multicast routers, that is R1 and R2, that depending on the group list maintained by router R could be the recipient of router R in this network. Routers R1 and R2 may be distributors for some of these groups in other networks, but not on this network. So now a host or router can join a group. A host maintains a list of processes that have membership in a group. When a process wants to join a new group, it sends a request to the host. And the host adds some of the name of the process and the name of the requested group to its list. If this is the first entry for this particular group, the host sends a membership report message. If this is not the first entry, there is no need to send the membership report since the host is already a member of the group. It already receives the multicast packets for this group. The protocol requires that the membership report be sent twice, one after the other within few minutes. In this way, if the first one is lost or damaged, the second one replaces it. So when a host sees that no process is interested in specific group, it sends a leave report. Similarly, when a router sees that none of the networks connected to its interfaces is interested in a specific group, it sends a leave report about that group. When a multicast router receives a leave report, it cannot immediately purge that group from its list because the report comes from just one host or router. There may be other hosts or routers that are still interested in that group. So to make sure, the router sends a special query message, inserts the group ID or multicast address related to the group. The router allows a specified time for any host or router to respond. So if during this time no interest is received, the router assumes that there are no loyal members in the network and purges the group from its list. A host or router can join a group by sending a membership report message. It can leave a group by sending a leave report message. However, sending these two types of reports is not enough. Consider the situation in which there is only one host interested in group, but the host is shut down or removed by the system. The multicast router will never receive a leave report. Now, how is this handled? So, the multicast router is responsible for monitoring all the hosts or routers in a LAN to see if they want to continue their membership in group. The router periodically, by default, it can say that it is every 125 seconds, it sends a general query message. In this message, the group address field is set to 0.0.0.0. This means that the query for membership continuation is for all groups in which a host is involved, not just one. The router expects an answer for each group in its group list. Even new groups may respond, and the query message has a maximum response time of 10 seconds, and the value of the field is actually 100, but this is in tenths of second. So when a host or router receives a general query message, it responds with the membership report if it is interested in group. If there is a common interest, that is two hosts, for example, are interested in the same group, then only one response is sent for that group to prevent unnecessary traffic. And this is called a delayed response. And now you can note that the query message must be sent by only one router, normally called the query router, also to prevent unnecessary traffic. So, to prevent unnecessary traffic, IGMP uses delayed response strategy. That is, when a host or router receives a query message, it doesn't respond immediately. It delays the response. Each host or router uses a random number to create a timer which expires between 1 and 10 seconds. The expiration time can be in steps of 1 second or less. A timer is set for each group in this list. And for example, the timer for the first group may expire in 2 seconds, and but the timer for the third group may expire in 5 seconds. So each host or router waits until the timer has expired before sending a membership report message. So during this waiting time, if the timer of another host or router for the same group expires earlier, that host or router sends a membership report. So the report is broadcast. The waiting host or router receives the report and knows that there is no need to send a duplicate report for this group. Thus, the waiting station cancels the corresponding timer. Thank you.